Afternoon. Good afternoon, everyone. My name is Rohit Agarwalla. I'm a technical lead at Cisco Systems. Most of the audiences that I speak to fall in one of the three categories. First, they want to understand what is Cisco's OpenStack strategy, what are the different areas that Cisco is actually contributing code to. Second, if they have a Cisco solution in their environment, how they can integrate it with OpenStack. And thirdly, if they are bringing up an OpenStack environment, how they can scale their networks using Cisco solutions. So at a high level, this is the agenda that I'm going to be talking today. I'm going to give you a quick overview of what is Cisco's OpenStack strategy, what is the different areas with partners, customers, as well as our engineering efforts that are focused around OpenStack. Then I'm going to cover at a high level, what is the Neutron OpenStack architecture? What are some of the limitations with the solutions that we have today? And why would you want to consider other vendors' solutions? And then we'll segue into talking about the Neutron Icehouse contributions and the plugins and the drivers that exist for Cisco solutions. And finally, we'll have the summary as well as some of the use cases of deploying one of the Cisco's Nexus plugins. So Cisco and OpenStack actually started right at the beginning of when OpenStack was growing around in 2011. I was actually one of the core community members as well, contributed in the initial Neutron plugins. And as of today, what we see is Cisco contributing code across different OpenStack projects. Predominantly in Neutron, from both the API perspective as well as from an architecture perspective to the southbound product integrations, Cisco's contribution in Neutron is at various levels. Now, this also spills on to other projects such as Horizon because you want to enable the plugin integrations within Neutron to be able to access through the Horizon GUI dashboard. Similarly, Cisco's UCS product systems that provide compute services, Cisco is allowing customers to be able to deploy OpenStack on those systems seamlessly, also enabling the storage angle to it. Cisco is also participating as a foundation board member. Cisco's VP of Cloud Computing, Lou Tucker, he's the vice chairman of the OpenStack board. We also have our newly elected Neutron PTL, Kyle Mystery, as the leading member of the Neutron community, as well as we have other core and non-core community members across several different projects. The second area that Cisco is heavily contributing in OpenStack domain is towards engineering and automation. So what I mean by that is Cisco's is allowing at deploying OpenStack at scale by automating the deployment aspect of it. And it is doing that by using Puppet modules for a lot of the OpenStack services. And we are also providing reference architectures such as the high availability for OpenStack services that allow you to deploy OpenStack in a production environment. Along the same lines, we are allowing scaling networks by providing integrations with Cisco solutions through plugins and drivers, and this include the Nexus hardware plugins as well as the unified fabric, the dynamic fabric automation driver and plugins, as well as the newly announced ACI, APIC, and the UCS systems. The third bucket is on the top right, in the bottom right, is with partners and customers. So Cisco is jointly working with our partners to provide something that's called Cisco Validated Designs, which is tested and validated OpenStack on Cisco gear. So this provides a great opportunity for our customers to actually pick something which has been vetted out by Cisco and its partners to quickly come up and deploy their applications in an OpenStack environment without much effort. So this is the pace that we're talking about even in today's keynote sessions, the agility and the velocity of you being able to integrate with an OpenStack environment that is vetted can be provided through Cisco. And finally, Cisco is also engaged into the cloud services part of it. So recently announced Cisco's intercloud effort is based on an OpenStack. And we are also running our applications such as the WebEx and including our customers' application. The use case studies include Comcast and PhotoBucket on top of our OpenStack infrastructure. With that, let's look at the presence that Cisco is having at the Atlanta Summit. At the top, I have a link of a blog post that covers a lot of the marketing events as well as the sessions that we have been talking. This is a list of all the general sessions that Cisco's OpenStack team is contributing in the Design Summit here in Atlanta. Now moving on towards the Neutron architecture. So the Neutron architecture, as most of you are aware, consists of a northbound REST API layer. We have core attributes and resources, as well as extension attribute and resources. The core APIs, the definition of core Neutron APIs implies that every core plugin needs to basically implement that API. Versus extensions, they are optional, they are vendor specific, and also provide some of the advanced services within Neutron, such as the routers, floating IPs, and the advanced services such as load balancer, VPN as a service. These core plugins, so today's one of the limitations that Mark and Kyle both discussed in the session just before this was that today's Neutron architecture allows you to just have one core plugin per OpenStack deployment. But in order to overcome that limitation, we have also come up with a modular layer 2 core plugin, which allows you to run multiple mechanism drivers and type drivers. And these mechanism drivers and type drivers allow you to basically interchange and have overlapping different network technologies as well as network mechanisms to program your infrastructure. Most of these network core plugins and the service plugins have open source as their reference implementation. As an open source solution as their reference implementation. Now there are certain limitations of using open source as your reference implementation within your production deployment. It might not match the feature set that you're using. It might not have the manageability aspect of it. What if something fails? How do you troubleshoot? How do you call upon for support? So these are the things that are missing from the open source solutions, and you look upon other options. So for example, for layer 3 services, Neutron uses IP namespaces on the host itself. It uses Linux routing tables and uses IP tables to implement NATing. These are all done on an x86 box. From a networking perspective, it is not that good because you're not using the networking features that are available on switches and routers to do their job. So that is why you want to consider other vendor plugins and drivers to implement those L3, L2, and advanced services. So along those lines, Cisco has contributed various solutions. It includes the top-of-rack Nexus plugin. It includes the virtual switch N1KV, and also includes the VPN as a service driver using the CSR 1KV in the Icehouse release. So I'm going to cover for each of those solutions how they integrate, what are the benefits of using that solution, as well as what extensions that we have enabled within Neutron to provide that integrated solution. So let's look at the Nexus 1000V solution first. And by the way, Balaji, who is the product marketing manager for the Nexus 1000 team, is also going to be talking about in more detail about this in tomorrow's vBrownbag session. So from a block diagram perspective, here you can see the Neutron server has the Neutron Cisco as a core plugin loaded up. And within that, we have the Nexus 1000V plugin. It communicates with the Nexus 1000V VSM. It's called the Virtual Supervisor module. For the members who are not familiar with, the Nexus 1000V consists of 2 modules, the VSM, which is the Virtual Supervisor module, and the VEM, which is the Virtual Ethernet module. The VSM can run on various systems, including your network node or the controller node, versus the VEM runs on the compute node itself, which allows the virtual machines, when they come up, to be plugged into the networking, whatever networking you have implemented for your OpenStack tenant. So the REST API call comes from the Nexus 1KV plugin into the VSM, which maps whatever has been the REST API on the northbound of Neutron into the VSM constructs. So in here, we see policy profile and network profile as 2 constructs that were provided within Neutron API as extensions that map to constructs within VSM. So a network profile allows you to define a segmentation scheme as well as a segmentation range for your Neutron network. In this example, you see I have defined on the top right VLAN as my segmentation scheme and a segmentation range of 400 to 499. Now this is an admin operation because you want the admin to define for a particular tenant what kind of network profile the tenant should be using. The tenant in the network will be able to create that network using the network profile that has been defined by the administrator. So in the second line, you see I create a network with a network name and refer to the N1KV profile network profile ID. And this maps to the network segment pool within my VSM. So there is a one-to-one mapping between the network profile as well as the network segment pool. The second extension that we have contributed for the N1KV solution is the policy profile construct within the Neutron API. So a policy profile, as most of you are already aware, is within the VSM is called a port profile. Within the port profile, you can define constructs such as ACLs, QoS policies, and the Neutron N1KV plugin will periodically be polling the VSM to get the list of all the policy profiles. And using the policy profile list that is in the third CLI command, and in the fourth, when I am actually creating a port within Neutron, I can make use of that policy profile. So a policy profile within Neutron maps onto a port profile within the VSM. So using two of these extensions, I can actually integrate a lot of the constructs that most of us are familiar with while using VSM into Neutron. So what are some of the benefits of using the N1KV versus OVS or any other Linux bridge open source solutions? Well, the first one is to be able to use the network profile. So as I discussed with network profile, you can define your segmentation scheme. You can have VLAN, VXLAN, VXLAN with a sub-profile of multicast or a unicast, or define a trunk profile as well. So an admin can define these profiles, and your network tenants can make use of these profiles to configure the networks. Of course, when using VXLAN, you can make use of the VSM feature of making it work in the unicast mode versus the multicast mode without any actual features being implemented within Neutron. So that comes as an additional benefit of using the N1KV as a plugin. The second benefit is, of course, like I said, policy profile allows you the flexibility to define the ACLs and QoS, which the Neutron N1KV plugin can pull and allow the ports that are created within Neutron to make use of. So the administrator, the security administrator, can actually work separately and define these policy profiles with the necessary ACLs and QoS, and when the VMs come up within the tenant networks, those ports automatically inherit those attributes in the network. And finally, the VXLAN gateway service. So if you have an environment in which you're running VXLAN plus VLAN, you would want to have a VXLAN as a gateway service VM to enable the conversion between VXLAN to VLAN and vice versa. Now, through the port profile, through the network profile mechanisms, N1KV already provides a profile of basically gatewaying all the traffic that needs the conversion from VXLAN to VLAN. So this is again an additional benefit of using the VXLAN gateway within the N1KV plugin without much change within Neutron. Now let's look at the CSR 1000V and the VPN service driver that is also as part of the Icehouse release in Neutron. So as I was referring back to the reference architecture of Neutron, we know the advanced services fall into the service plugin architecture. So the service plugin has the Cisco VPN service driver, which makes RPC calls to the VPN agent, which finally sends those to the device driver to actually configure the CSR instance onto on the compute nodes. This solution, although is not right now integrated with Nova to enable the NFV aspect of it, that is, you won't be able to manage the CSR KV instance through Nova itself. But in Neutron Icehouse, what exists today is to be able to configure the CSR1 KV instance for the VPN service, for the VPN IPsec site-to-site connection. And this block diagram on the top right gives you a high level of how this would work. So if I wanted site 1 to be able to talk to site 2, I would have to set up a router that is using the reference implementation within Neutron along with the CSR1 KV instance. Both of these things would have one leg within the private network that needs to be connected and one leg in the public address that will provide me the IPsec tunnel into the site 2. Similarly, in the site 2, I would have a router and a CSR 1 KV instance in both the two networks. Now, when a packet is sent from site 1 to site 2, it hits the router gateway that says that I need to reach a VM on site 2, so it will send the traffic to the CSR 1 KV instance, because it will have a route that says if a packet is going to site 2, send it to the CSR 1 KV instance, and the CSR 1 KV instance will basically tunnel that into an IPsec tunnel and send it across the public network. On the other end, the CSR 1 KV would have been configured to receive that traffic, and decapsulate the tunnel, and forward the traffic to the right VM within that site. So what are the benefits of using the CSR1KV as a VPN driver? Well, first of all, it is a Cisco secure VPN qualified solution. It is a vetted solution. It has been tested. It has much more advanced functionalities than just using for VPN. What we are going to see in the following releases is the CSR1KV instance be able to use for layer 3 purposes as well as for firewalling purposes. And we are also providing NFV-based architecture of using the CSR1KV instance. So there are multiple benefits and multiple services that can be used alongside when using a single CSR1KV instance within your deployment. Now with the NFV architecture that we are proposing, you would be able to also scale your CSR1KV instances by deploying multiple of the CSR1KV instances and load balancing them across different instances. The final solution is that's available in the iSaaS release is the Neutron Cisco Nexus plugin. Now, consider a use case where you have multiple compute nodes running. You want to be able to connect them with a top-of-rack switch. And when you're provisioning your Neutron networks, you would ideally want your virtual segments as well as your physical segments to be provisioned end-to-end in a programmatical manner without any interference. So the Nexus plugin provides you exactly that functionality. If you have multiple compute nodes that are connected to one or more Nexus top-of-rack switches, the Nexus plugin or driver will allow you to configure the Nexus top-of-rack switch with the appropriate layer 2 interfaces as well as layer 3 interfaces. So here we also show that it's a plugin and a driver. The purpose of that is we have a Cisco Core Nexus plugin as well as modular layer 2 mechanism driver in the iSaaS release. So depending upon your deployment, you can make use of either of those solutions to program the Nexus top-of-rack switch. So what are some of the benefits of using the Nexus plugin? Well, it works with across all the Nexus line of switches because it exposes the same northbound interface to the Nexus driver. So we use the NC client and send an XML snippet onto the Nexus top-of-rack switch, which can understand that XML snippet and configure the switch. This also works with the newly launched 9K, Nexus 9000K in the standalone mode. In the ACI mode, we are working towards a solution that will be available in the Juno release. So the second benefit of using the Nexus plugin is that it allows dynamic provisioning of VLAN as well as SVI on the top-of-rack switches. Now, when I say dynamic, what I mean by this is that we do not allocate resources in advance. So the allocation of resources happens only when the VM is actually coming up on that network. So here in the picture, you can see that there is a create update port request that is sent to Neutron. So we hook onto that request from Nova into the Neutron server. And the Nexus plugin basically takes that create port request and sends the request onto the top-of-rack switch to configure that segmentation ID. Similarly, with SVIs, we provision the SVI, which is a layer 3 construct on the Nexus top-of-rack switch to map the default gateway IP address onto that VLAN. So we achieve a layer 3 segmentation by configuring an SVI interface on top of the VLAN network on the top-of-rack switch. Similarly, this also gets deprovisioned when the VM goes away. So we hook onto a delete port call, which allows the VLAN to be removed from the interface that's connected to the compute host on which the VM is coming up, as well as removing the VLAN from the switch if that was the last VM for that particular tenant network. And the last benefit is, of course, it allows us to update the top-of-rack switch as and when the VM migration between hosts happens. Again, similar mechanism, because as we move from one host to the other host, Nova allows us to send a create port request on the new host, and we basically, using our topology that has been configured in our INF file, figure out which appropriate top-of-rack switch needs to be configured with the right VLAN. Now let's look at some of the use cases of using the Nexus plugin, and this would give you a very good idea of what the different references that I have mentioned so far and how they map to an actual OpenStack deployment. So our first use case is using the Nexus, having an OpenStack environment without actually using the Nexus plugin. So in this case, if you can see, I have a controller server which is running the Neutron service and just has the vSwitch plugin. I have two compute servers that have VMs belong to two different networks for the same tenant. What I would do if they were connected using a single top-of-rack switch, I would basically allow all VLANs on the interfaces that are connected to my compute nodes. Now, we all know configuring VLANs on all interfaces that are connected to the compute nodes on a single top-of-rack switch has its scalability limitations. So this is not an ideal situation, and you would want to configure these VLANs as and when the VM for that particular tenant network comes on. So this is the first use case, that you have VMs that are part of the same segment but are on two different compute nodes and are connected via a top-of-rack switch. So here you can see that the tenant demo has a VM1 on compute server 1, which has a VLAN 150 configured, as well as the compute server 03 has a tenant demo with a VM2 with VLAN 150. And both interface Ethernet 1/12 and Ethernet 1/9 on the top-of-rack will be configured dynamically with the appropriate VLAN when these VMs come up. Now, the second use case, if I spin up a VM for a different network that has a different segmentation ID, in this case VLAN 151 on a compute server 03, the Nexus plugin would actually dynamically configure the appropriate interface that's connected to that compute host. So in this case, Ethernet 1/9 would be configured with VLAN 151 because that's the network segmentation ID for that network within Neutron. And the third use case is when you want these different VMs on different networks to be able to communicate with each other. In that case, you would have to be you will be configuring layer 3 default gateways for those tenant subnets onto the top-of-rack switch. So in this case, what we see is that when we associate the subnet with the Neutron router, the Nexus plugin goes ahead and configures the top-of-rack switch with an SVI interface, as well as configures that SVI interface with the appropriate default gateway IP address of that tenant subnet. So in this picture, for VLAN 150, we see that 10.001 has been configured as the SVI interface, as well as for VLAN 151, 10.011 as the SVI interface for that VLAN. Now, what this would allow is basically these two networks to have internal communication between each other. Traditionally, with the reference implementation within Neutron, these default gateway are actually configured on the OVS bridge, if you're using the OVS plugin, that is, and you have QRs and QBs as the ports on those bridges, which will have the default gateway IP addresses. Now, as you can imagine, debugging with QRs and QBs would just be a lot of, you have to understand how that debugging works versus being familiar with the Nexus environment where you know where to run the appropriate tools and capture the packets in order to do your debugging. So one of the other things that we are working towards in the Juno release is to provide a layer 3 feature parity with the Nexus top-of-rack switch. So you'd be able to use the floating IPs, the external gateways, in addition on the top-of-rack switch, including the internal subnet SVI interfaces. So with that, I think so I've covered most of the solutions, or all the solutions that are part of the Neutron ISA's release. In summary, what I would want to, what I want you to take away is that OpenStack is becoming the default standard in data standard orchestration. Cisco's broad-based OpenStack strategy cuts across, customers, partners, services, and we are seeing that OpenStack being adopted with production-ready solutions in various areas. OpenStack networking, which has some of its limitations with using the open source reference solutions, can be overcome by using Cisco solutions. So you can scale your environment, make it high performance, make it scalable, as well as easy to troubleshoot, and with a lot of features that works in your environment using the Cisco network solutions. And of course, like I mentioned within all my talk, there are many more things that are going to be available with the Juno release, and these include such as the DFA driver, the APIC driver, and the layer 3 and the VXLAN support on the top-of-rack switch. Thank you.